Hello, and welcome to another edition of Math, Music, and More. In today's discussion, we're actually going to use synthetic division again and apply it to discounted cash flows and how you actually determine the enterprise value of a firm. But in fact, I'm just going to focus on one component of that. That component is called the terminal value. And then an interesting sort of epiphany that I had a little bit earlier today. I'm going to talk kind of fast because I'm under pressure, but let's get right to it. If you remember from synthetic division, we had a ratio, something like x over 1 minus x, and we showed using synthetic division, right, x, 1 minus x, that has to equal x plus x squared plus x cubed to infinity. And then I pointed out that, well, what if x would be something like 1 over 1 plus I, where I would be the interest rate of a perpetuity. And we actually found that this thing, if you valued it out to infinity, that infinite sum would actually be 1 over I. That, again, is the equation for perpetuity, assuming you get $1 ad infinitum at a certain interest rate I. So what are we talking about with terminal value? Here's where it comes in. In the terminal value calculation of a company, you look at the free cash flows, and let's say you're going 10 years out. Well, then you'd look at the free cash flows in year 10, and then you'd actually multiply it by whatever you think the growth rate in perpetuity is. The business is going to grow so and so much every year in free cash flows. We call that G. And then you actually divide it by the weighted average cost of capital minus G. This is just sort of a standard formula that people use for the terminal value. And I forget what it's called. But anyway, again, final free cash flows from whatever your forecast period is. Maybe you have lots of details and you're confident that you can actually forecast something for 10 years. But then it's 1 plus G divided by the weighted average cost of capital minus G. That gives you the terminal value 10 years out. And I want to show you how you can actually use synthetic division to actually show that this is the case, rather than just like assuming that everything that you're told is true, always just relying on faith. So let me go ahead and erase this for a second and show you this. Quick, to make the math very simple, we're going to assume that the free cash flows in year 10 is just $1, because that'll tighten the math significantly. So let's go ahead and do that. So notice that if in year 10 it was actually $1, that means in the next year it was actually going to grow, remember? And that would be 1 times 1 plus G. But because it's 1 year out, we'd have to discount it back, right? And what do we discount it back by? 1 plus the weighted average cost of capital. And similarly, in the next year, well, you'd have 2 years worth of growth. So that would be 1 times 1 plus G squared over 1 plus WACC squared. And you notice the pattern. You're going to have this continuous ratio of 1 plus G over 1 plus WACC squared cubed to the 4th power out to infinity. So that means that the answer, if it's just going to be paid $1 all the time, remember how we said via synthetic division, we proved this, is just x over 1 minus x. But in this case, x actually equals 1 plus G over 1 plus WACC. So all we have to do is go back to that formula that we had. Well, what's x over 1 minus x, if this is what x is? Let me give a little more room again. Well, if that's what x is, then it's 1 plus G over 1 plus WACC. Let me see if this is legible because there's a lot of glare. You know what? Let me put it on this side of the board instead. Hold on. So x over 1 minus x would then equate to 1 plus G over 1 plus WACC. And remember, it was divided by 1 minus x. Well, that would be 1 minus 1 plus G over 1 plus WACC. And now this thing just gets simplified by turning that into 1 plus WACC over 1 plus WACC. Right? And then 1 plus WACC minus 1 plus G, but now you're making it a minus. This all gets simplified to what? 1 plus G over 1 plus WACC over 1 plus WACC minus 1 minus G over 1 plus WACC. So this is just arithmetic, so hopefully this is all pretty straightforward, and hopefully you can see this ratio here. But these 1 plus WACCs cancel out. And then you're left with 1 plus g over 1 plus whack minus 1 minus g is whack minus g, which is exactly the formula that we had before, only we had it all multiplied by free cash flows in year 10. So there, using synthetic division, we could actually prove it. But here's something that I figured out this morning that I thought was pretty interesting. Let's say your WACC, your weighted average cost of capital is 12%. That's kind of like an average number. Many companies could have that. Depends on your cost of debt and your cost of equity. And let's say your growth rate is only 2%, right? Then what it turns out is that you're really taking your free cash flows, you're growing it just one time, and then you're dividing by 12% minus 2%. Well, what is that? That's like dividing by 10%. But what's dividing by 10%? It's like multiplying by 10. So in my opinion, this is a great way to demonstrate analytically these PE ratios that we're constantly hearing about, right? PE ratios, they're very much dependent on the industry, but they can sometimes be something like 10. For every amount of earnings that you have, you multiply it by 10 and you get what you think the price of the firm would actually be, the enterprise value. Well, this is a great way to justify that. If you think that the WACC is 12% and the growth rate is 2%, basically using the synthetic division and the resulting formula, it's the same thing as basically just using a PE ratio of 10. I think that's a very interesting insight and a way of sort of connecting the dots between things. And I wish in business school they would have pointed stuff like this out. They always give you the tools, but they never really theorize enough and show the connections. That's why the physicists, the engineers, the mathematicians always have fun at business school. I hope you do too. If you ever go, take care everybody. Bye.